So it can happen that we have a contour, something like this rectangular one, which needs to effectively pass through poles. So if we've got a pole, for example, on the real axis, and we really want an integral which passes along the real axis, then what can we do? Well, what we do, in fact, is we deform the contour. So this gamma here refers to this blue line, the deformed contour. We do a little semicircle around smooth parts of the contour, which want to pass through poles. And if we get to a corner, right-angled corner, where there's a pole, where we want to put a contour, then we deform it via a sort of quarter circle. So I'm going to refer to the deformed contour, the blue line, as gamma, and the one that we originally wanted, with this dashed red line here, as gamma tilde. So what happens? Well, basically what happens is that we treat these poles on the contour as if we have a deformation of the contour gamma in a semicircle, we treat them as half a pole, and if we've got a quarter circle going around, we treat them as a quarter of a pole. So we modify the residue theorem in a sort of obvious way then. So we think of, we've still got the ordinary poles inside the contour, so that's 2 pi I times the residue of those, Zj, inside gamma, inside the simple closed loop. Then for contours, for poles actually on gamma tilde, then we just do half of what we would normally do. So half of 2 pi I is pi I times the residue. And then finally, less commonly, sometimes happens that you get a pole on a right angle corner of the contour you want, in which case you just need a quarter of 2 pi. So you get pi by 2 I times the residue at that point. Right, so what I haven't said yet is that this is true in the limit as I'm going to make these circles, these semicircles and quarter circles, radius r. So both of these I'll make radius r. So this becomes true in the limit as the radius of these little, what are called indents, these little indents, go to 0. They never reach 0 because otherwise they would hit this singularity, but in the limit as r goes to 0, then this becomes true.